So this is the second part, part B, under the same question. So this is the particle attached to a fixed point by an elastic string. So what we have showed earlier is that the particle behaves simple harmonically within this region O and B. So you could write under there from A to B, or within this region A and B, the particle will not be under tension. The string is not under tension, it is slack, therefore it does not behave simple harmonic. That means there are no forces there. So you cannot get the characteristic equation. So we can say that within O and B it behaves simple harmonic. Right. So second part, if gently released, now they say that the particle is stretched to a point B such that OB is length L. Length OB is L. From A to B, length is L. If this is the case, and at this point it is gently released, that means the velocity of the particle at this point, point B, is 0, then it is released. Find the amplitude and the velocity at O. First find the amplitude. Now we have the characteristic equation. So we know there's another equation we can use for the velocity. In general, velocity v squared is equal to omega squared a squared minus x squared. Now we can use this equation to get the amplitude, right? So how do you define the amplitude? Amplitude is, to find amplitude, so definition of the amplitude is the point where the velocity becomes 0, v is equal to 0. This implies a squared minus x squared is equal to 0. But if v is 0, omega is a positive quantity, this cannot be equal to 0. That means only this expression has to be 0. So where is v equal 0? This is gently released point from the point B. Therefore, a squared is equal to x squared. This implies a is equal to x, which is equal to L. Right? Now the amplitude is L. So let's write it here. A is equal to L. Right. Then find the amplitude and the velocity. Velocity at O. So when it is released, you know it has an acceleration towards the towards O, this fixed point. That means the particle will be accelerating in this direction. So the velocity increases, and it is given by this formula here. So what is the velocity at O? To find the velocity at O, you have to make x equals 0, because at this point the x value is 0. So velocity, let's say u squared, let's say v squared at O. V squared sub 0, or sub O, sorry, omega squared. Now a squared is L squared minus x has to be 0. So this should be omega squared L squared, and velocity at O would be omega times L. So you know this equation because at the center you have the highest, you have the maximum velocity of the particle. So this should be, now omega is root g over L, root g over L times A is L. Therefore, the final answer is GL, root GL.